F325 Unit 2 Module 2 Energy. Lattice enthalpy. This is the enthalpy change when 1 mole of a solid ionic compound is formed from its gaseous ions under standard conditions. Hess's law states that if a reaction can take place by more than one route and the initial and final conditions are the same, the total enthalpy change is the same for each route. The standard enthalpy change of formation is the enthalpy change when 1 mole of a compound is formed from its constituent elements in their standard states under standard conditions. Standard enthalpy change of atomization is the enthalpy change when 1 mole of gaseous atoms is formed from its element in its standard state. The first ionization energy is the enthalpy change when 1 mole of gaseous 1+ ions is formed from 1 mole of gaseous atoms by the removal of 1 electron from each atom. The second ionization energy is the enthalpy change when 1 mole of gaseous 2+ ions is formed from 1 mole of gaseous 1+ ions by the removal of 1 electron from each 1+ ion. The first electron affinity is the enthalpy change when 1 mole of gaseous 1- ions is formed from 1 mole of gaseous atoms by the addition of 1 electron to each atom. The second electron affinity is the enthalpy change when 1 mole of gaseous 2- ions is formed from 1 mole of gaseous 1- ions by the addition of 1 electron to each 1- ion. You must include state symbols when writing out these equations. The standard enthalpy change of solution is the enthalpy change when 1 mole of a compound is completely dissolved in water under standard conditions. The standard enthalpy change of hydration is the enthalpy change when 1 mole of isolated gaseous ions is dissolved in water, forming 1 mole of aqueous ions under standard conditions. Entropy, S, is the quantitative measure of the degree of disorder in a system. The standard entropy change of reaction is the entropy change that accompanies a reaction in the molar quantities expressed in a chemical equation under standard conditions, all reactants and products being in their standard states. Delta S is the sum of the entropy of the products take away the sum of the entropy of the reactants. If delta S is positive, then the system becomes more random. If delta S is negative, then the system becomes more ordered. Delta G, the free energy change. This is the balance between enthalpy, entropy and temperature for a process. Delta G equals delta H minus T delta S. A reaction is feasible and can take place spontaneously when delta G is less than 0. When you're calculating delta G, don't forget to convert entropy to kilojoules by dividing by 1,000, because usually entropy is quoted in joules. Oxidation is the loss of electrons or an increase in oxidation number. Reduction is the gain of electrons or a decrease in oxidation number. A redox reaction is a reaction in which both reduction and oxidation takes place. Oxidation number is a measure of how many electrons an atom uses to bond with atoms of another element. An oxidizing agent takes electrons from another species and is itself reduced. A reducing agent adds electrons to another species and is itself oxidized. The standard electrode potential is the EMF of a half cell compared with a standard hydrogen half cell measured at 298 K, with solutions being 1 mole per dm cubed and a gas pressure of 1 atmosphere. The standard cell potential of any cell is the difference between the standard electrode potentials of each half cell. The positive terminal take away the negative terminal. This concludes this topic. Thanks for watching.